Here we have a SAT math problem. Okay, let's go to the question. A surveyor drew the diagram about to find the distance across a pond. If AB equals to 150 meters and AD equals to 90 meters, what is the distance in meters from point B to point D? Okay, here we have the length of this line segment AB, that is 150, and the length of this line segment AD, that is 90, and we have to get the length of this BC, that is a distance from point B to point C. Here we have a right angle, and this side also will have a right angle. Now let's consider the two right triangles, the right triangle ABC over here and the right triangle ABD over here. Okay, now let me consider the interior angle of the vertex B over here in the right triangle ABC. Let me write the angle B over here. Now let me consider the interior angle of the vertex D of the smaller right triangle, that is the angle D. So these two angles are congruent because both of them are right angles. Now let me consider the interior angle of the vertex A in the bigger right triangle ABC over here. Let me write it, angle A. Now let me consider the interior angle of the vertex A in the smaller right triangle ABD over here. That is angle A. So this one and this one are congruent by reflexive property. Okay, these are the two interior angles of the bigger right triangle ABC, and these are the two interior angles of the smaller right triangle ABD. Since the two interior angles of the bigger right triangle ABC are congruent to the two interior angles of the smaller right triangle ABD, by angle similarity postulate, the two right triangles are similar. Okay, now let me write the vertices in order. Let me take the vertex A in the bigger right triangle ABC, and the corresponding vertex in the smaller right triangle ABC also is the same A, because A is a common vertex for both the triangles. Now let me consider the vertex B in the bigger right triangle ABC. The corresponding vertex in the smaller right triangle is D, because at B and D we have right angles. Let me write it over here. The third vertex in the bigger right triangle is C, and the third vertex in the smaller right triangle is B. So these two triangles are similar by angle similarity postulate. Okay, here let me consider the side AB in the bigger triangle, because we have the length for AB. That is, let me write AB over here. What is the corresponding side for AB in the smaller triangle? That is AD. We have to consider that as at the same position. So AB over AD. Now let me consider the side BC of the bigger right triangle. The corresponding side of the smaller right triangle is DB. BC over DB. Since these two triangles are similar, the ratios of the corresponding sides must be equal. Okay, here what is the length of AB? That is 150. We can plug in 150 for AB. What is the length of AD? That is 90. We can plug in 90 for AD. And what is the length of BC? That is what we have to find. We can write the BC as it is. Do we have the length of this DB? No, we do not. Actually, the length of the line segment we have over here. In this smaller right triangle ABD, we can get the length of this line segment DB using Pythagorean theorem. But even without using Pythagorean theorem, we will be able to get the length of this line segment DB over here. Now, let's consider the hypotenuse AB over here in this right triangle. So, it's a multiple of 5. So, we can write this one as this 150 as 5 times 30. And let's consider the length of this leg AD over here. It's a multiple of 3. So we can write this one as 3 times 30. Okay, here in this right triangle ABD, the length of the hypotenuse is a multiple of 5, and the length of this leg is a multiple of 3, and both of them have the same factor 30. So clearly this smaller right triangle ABD is a 3, 4, 5 right triangle. So since the length of the hypotenuse is a multiple of 5 and the length of this leg AD is a multiple of 3 with the same factor 30, then the length of this leg BD has to be a multiple of 4 with the same factor 30, that is 4 times 30. This is the length of this leg BD. 4 times 30 is 120. So 120 is the length of this leg DB. We can plug in this 120 for DB over here. Okay, let me do it. Okay, here both 150 and 90 have the greatest common divisor 30. That is 30 goes into 90 3 times and 30 goes into 150 5 times. We get 5 over 3 equals to BC divided by 120. Now let's multiply both sides of this equation by 120 to solve for B. This 120 will cancel out. Here 3 goes into 3 1 times and 3 goes into 120 40 times. When I multiply this 40 and 5, I am getting 200. That is 200 is the length of BC. So that is a distance from point B to point C is 200 meters.